Hi all, welcome to Analytics Fusion. So in today's video, we will talk about one of the most important data science interview question that is often asked in the interviews. So this question is more about the scenarios. So we will not talk about theory or the practical aspects. We will talk about some of the scenarios which we face while implementing a data science model in our day-to-day work. So let's assume you build a multiple regression model. Okay, you are fine, you build a good model, you are happy, but somehow you have reasons to believe that some of the predictors or the features used by you are correlated. Now in that scenario, you don't know what will happen to your results. You are worried how my results will get impacted. What if I need to remove those, or I shouldn't remove those? Second, how would you deal with that problem? How would you remove the correlation? Okay, now this problem comes under the umbrella of multicollinearity. Now multicollinearity is basically when two or more features are correlated with each other. That is multicollinearity. Now multicollinearity directly will not impact your accuracy or the RMSE. Okay, however, it will impact your model coefficients and the p-value. Now what impact it will have on model coefficients? So for example, when two or more variables are correlated, the coefficients of this predictor, so the coefficient which we got like beta naught, beta 1, beta 2, they become highly unstable. So suppose if you build a model on, let's say, dataset 1, and there is similar dataset, however just a reasonable change in dataset 2. If you build a model on dataset 2, your coefficients will vary very high. Now this shouldn't happen. So suppose if you are building a model on, let's say, April dataset, and you build a model on, let's say, data on the dataset of May, ideally your coefficient should be slightly changed. But if you have multicollinearity in the data, your coefficients of the predictors will change a lot. Second is with the sign itself. So for example, we know sales and price are inversely proportional. When you increase the price, sales of a product will go down. However, if you have multicollinearity in the data, you might get the opposite sign. Okay, we were expecting a negative sign for a price coefficient. However, it might happen, you might get a positive sign for the price coefficient. Second issue is with the p-value. Now what happens? So important variables generally have lower p-value compared to a threshold. However, if there is a case of multicollinearity, you might get a very high p-value for the important variable, which will ultimately let you say that is statistically insignificant. However, that scenario is not in actual. So consider a case below. Let's assume we have three predictors, x1, x2 and x3, and a response variable y. You know priori x1 and x2 are important variables. However, when you will see the result, what will happen, since these are collinear variables, now p values for both these coefficients will be very high. What it will show you, that you should reject these variables while building the model. However, if you would have consumed only one variable, this p-value would have gone down drastically. Okay, so this kind of a problems happens with the when you have the multicollinearity. Now having said that, you understand the problem. Now how would you deal with the problem of the multicollinearity? So there are multiple strategies which we can deploy to deal with the multicollinearity. First is we remove the highly correlated feature. So suppose in the example above, from the x1 and x2, you just simply remove one variable and that will solve your problem. Or second is you can combine the predictors. So for example, in the example above, you can combine predictors like x1 and x2 into x1 plus x2, or x1 times x2, x1 divided by x2. So this kind of this things also reduce your multicollinearity. Third approach is the principal component. So principal component basically transform your, let's say, x features into n features, so which will be highly uncorrelated. Fourth is the VIF, default strategy to deal with the multicollinearity. A threshold of 5 or 10 on a variables is worth considering removal. If a variable get a VIF of, let's say, 5 or 10, you can remove it basis how many features you want to contain in your model. and there are regulation technique like rich, lasso, elastic net. All of these techniques also helps you to reduce the multicollinearity. Now, by applying all these strategies above, the impact of multicollinearity can be mitigated if not 100% resolved, leading to a more reliable and more stable model. So this is one of the problem which we face on a day-to-day basis in a data science. Okay, to understand, to learn more about this kind of a scenario based questions, just subscribe to our channel Analytics Fusion. Comment if you have any issues. Thank you.